Similar to the other two streams and rivers lecture, you're going to take Streams Part 3 quiz as you listen to this lecture. This lecture is going to be all about flooding and then what we can do about flooding. So hopefully you've never had the experience like these kids at this house here, where your house floods and then you're just fishing in your front yard. So I assume we all know what a flood is. Geologists have a very specific definition of what a flood is, though. And a flood is basically when a river overflows onto the floodplain. So you can have the height of the river come up in any situation, and we don't really call that a flood yet. It's only a flood once it actually makes a connection with the floodplain or the flat land that's surrounding it. So this would be an example. You have your regular river channel right here, but as soon as water overflows onto a floodplain, then we call it a flood. So we have a couple examples here. This one was from Japan, but we just have this flood flowing through this channel. And then we have this kind of rural stream that has overflowed this bridge here as well. So that would technically be a flood because it's now overtopped its banks and spilled out onto the flat area adjacent to the channel. So we're going to talk about what causes floods. I realize that you all probably are already familiar with what causes floods, and I get that. So I'll start with the simplest and easiest one, and it's just excess rainfall. So you can either have excess precipitation in the form of too much rain in a very short period of time, or you can have something like a snow event that all melts pretty quickly, and that's going to cause a flood. So you can have too much snow, or you can have too much rain in a very short period of time. So an excellent example of this would be Leominster in September 2023. So Leominster had the big flood. They basically got 11 inches of rain in a very short period of time. Too much rainfall for the ground to handle. Excess precipitation led to flooding of the city and the river, the Nashua River itself. So as an example, if it rains too much, this is Richmond, Virginia, the James River under normal flow, and then this is the James River during flood conditions from too much rainfall. So that's the most straightforward one. So there are other ways that floods can occur or that they are exacerbated by human activities. And another example would be above average seasonal rainfall. So this means that if you normally get 10 inches of rain in one season, let's say in spring, maybe you get 20 inches of rain or you get 30 inches of rain. So you have above average seasonal rainfall, and that can lead to floods because you've gotten a lot more than you would normally get in that particular time of year. And maybe the area is not designed to handle that type of flow or that amount of water. So there's a famous flood that occurred in 1993 of the Mississippi River. And back in that particular year, what happened is that if the green in the bar graph here on the left side, this is just month, and then we have rainfall in centimeters by month. The green is showing you the average rainfall from 1961 to 1992. And then in 1993, the blue is showing you how much more rain occurred than normal. So if you look at March, 1993 had more rain than normal. If you look at April, slightly more rain than normal. May had more rain than the average. June had much more rain than the average, and July had almost 4 times as much rain than the average. So all of that water has to go somewhere. And what happened in the Mississippi River Basin, or the watershed, is that basically an area of 17,000 square miles, which is 2 times the size of Massachusetts, flooded and was underwater at some point in time. So the outline that I just showed here in blue is the outline of the region that was affected by flooding at that particular point in time. And again, it was about 2 times the size of Massachusetts, where areas were underwater. Just to show you some images, this is the Missouri River in 1993. This is close to Jefferson City, Missouri. And what you're looking at here is basically an interstate interchange, so like a cloverleaf interchange where you have 2 roads that are at an intersection, and then interstate crossed over the river. Normally the river itself should just be right back here where this bridge is, but the flooding was so severe that basically the river became, in some places, a half-mile wide. So that's above average seasonal rainfall. A third mechanism that can cause floods or make them much, much worse is human activities. Anytime we pave over a surface, that creates an impermeable area, so it prevents water from soaking into the ground. And if you stop water from soaking into the ground, then basically you cause flooding to occur. So cities have huge problems with urbanization. Whenever you flood, whenever you cover an area with concrete and asphalt, you can't allow water to soak into the ground, or water doesn't soak into the ground, so you're going to get a flood that will occur. Same thing, human activities put in dams. So anytime we create dams, dams create floods, or they can exacerbate floods, make them worse in some situations, or dams can fail and create floods that way. Another way is through construction. So any kind of building of roadways or developing plots of land for housing developments can create floods as well, because you are moving around soil. Soil is supposed to soak in water. If you're moving that soil around, you're preventing the amount of water that can soak into it, and you can create floods that way. Okay, so if we're looking at floods and trying to estimate floods, all across the US, we have a network of over 7,000 locations where you can instantly just use the computer and see what level a flood is in or a river is in. So these are called stream gauging stations. That's written down here if you're taking notes, but a stream gauging station. And what they look like are just these sheds that are on the sides of rivers. So they're not that exciting, but they're on the sides of rivers. And what's inside of that shed is a bunch of equipment that's designed to measure the height of the stream at all hours of the day. So many of these, they will take a data point and they will measure discharge or flow in a river every 15 minutes or every 30 minutes. And then it gets uploaded to a website and you can access it almost instantaneously to see where flooding is happening across the US. So this is used to make models and predictions of flooding. So the data that's actually produced from those stream gauging stations, those sheds that I just talked about on the last slide, they produce something called a hydrograph. So what a hydrograph is a graph of water graph, hydrograph. And they usually have date or time on the x-axis. So this hypothetical one here from the Cuyahoga River in Ohio goes from July 8th to July 22nd. And then we have the height of the water in terms of meters. So this one ranged from 1 meter up to about 2.5 meters. The arrows that I have here indicate when a storm event happened. So if it rains, you can see the storm, the water goes up. If it rains again, water goes up. It can also show you when water comes down as well. So if we're trying to measure how often a flood occurs on a given location, we can measure something called the recurrence interval. So we talked about this a little bit with earthquakes a couple lectures ago. So in earthquakes, the recurrence interval was telling you how often you would expect an earthquake to happen on a fault like the San Andreas Fault. If we're looking at recurrence interval for flooding, it's telling you how often you expect a flood to occur on a river. So for example, if you have a recurrence interval of 50, you expect a flood to occur every 50 years on average on that particular river, a flood of a similar size or similar magnitude. So we can look at recurrence interval here. So on our x-axis here, we have recurrence interval. Starts at 1 on the left side. We have 100. So this is telling you that a large flood, in this case of about 25 cubic meters per second, occurs once every 100 years. So 1 out of 100 is a 1% chance of that flood happening every single year. As another example, let's say that you want to know how often a 15 cubic meters per second flood occurs. You get that number from over here, and you could go and intersect this line, and it would tell you that it occurs on average every 6 years. So you would have a flood of 15 cubic meters per second every 6 years or so, which would be about like 18% chance of happening every year. So where does this kind of graph come from? It comes from calculating recurrence intervals. The way that it's done is a recurrence interval is labeled as Ri, and then it has a simple equation. So it's n plus 1 divided by rank. N is the number of years measured. So let's say you go out to a river and you measure floods for 10 years straight. You have measured 10 years of data. So n plus 1 would be 10 plus 1. You divide that by rank, which I'll go through in a second. So rank is basically you can rank the largest flood that you had would be a rank of 1, and then you work your way down. The second largest flood is a rank of 2. Third largest flood is a rank of 3, and you can work your way down to understand the rank of floods and the recurrence interval associated with floods. So at this point, you should be able to answer questions 1 through 6 on the quiz. So if we're trying to control or prevent floods, we have a couple of mechanisms for being able to do that. There's a couple definitions that we need to talk about. So in terms of controlling floods, floods are costly. So it is beneficial to humans to try to prevent or adjust to water and flooding from occurring. So it kind of falls into two categories. The way that we tend to control floods is we either try to prevent them or we adjust to them. These are just some more pictures from that 1993 flood in the Mississippi that I was talking about from the above average seasonal rainfall. So just to go through the definition of these, prevention means that you are physically building a structure to hold back a flood. So man is coming in or human is coming in, they're building structures, they are building some kind of mechanism that is designed to prevent water from getting into a location in the first place. On the other end of the spectrum, it's a different way of thinking, but adjustment means that you accept that nature is going to do nature's thing and you get out of the way. So it's the idea that humans should not be building in areas that are prone to flooding. You adjust, you either change lifestyles, you change rules, you change regulations and laws to not allow people to live in an area that is prone to flooding. So adjustment is recognizing that nature will do its thing and things are going to flood. So you might as well just get out of the way, save yourself the trouble and the money. And prevention is building something to try to stop nature. So if you look at prevention, so building something to try to stop nature, these are artificial structures that will be built. So you can have levees. Levees are kind of an embankment, an area where you kind of just pile up some soil to create a much higher level that the river would have to rise to flood over into an area. So this is an example of a levee down here that was breached during Hurricane Katrina. Here's another example of a levee, but basically the idea is that you raise the bank of a river, so it has to rise that much higher to be able to flood in the first place than if it was flat and kind of in its natural state. Another example of a structure that's built would be a flood wall. So a flood wall would just be a vertical wall that's built located right next to a river or a stream. It can be a certain amount of height, usually based on models of what kind of floods you expect in an area. And the idea is just that it holds back water. So if you have a flood, it holds back water. So this is a terrifying picture to me. Up here, we got a boat up here in this flood wall, but the flood wall is doing exactly what it was designed to do. But personally, I would not choose to live on this street here at all. Adjustment, again, on the other hand, is accepting that nature is going to do its thing and that things will flood because they always have. So there's no point in trying to build a structure in an area that floods. So flood adjustment is adjusting our lifestyle instead of trying to control water. So examples of this would be restoring wetlands and then zoning codes. So in terms of zoning codes, if you have a river, typically what will happen is that there'll be what's called a designated floodway, which means that there is no construction whatsoever allowed in this particular zone here. That's a 20-year flood, so it has a 5% chance of happening every year. Or if you have a 100-year flood, you can build in it, but you have to flood-proof your construction. So you have to take further mechanisms of reducing your risk of living in that area for a 100-year flood. Then again, a 100-year flood is a 1 in 100% chance of happening every year. So 1% chance of happening every single year. So just to remind you, or just to let you know, so if you are in a state that is prone to flooding, you have to buy flood insurance. If you buy a specific house that's in a known flood zone, you also have to buy flood insurance in addition to homeowners insurance on your home. And up here in New England, we have some of the highest flood insurance premiums across the U.S. So in addition to your regular homeowners insurance, you have to take out a policy for flood insurance if your home is in a risky area, and you might have to pay an additional $1,200 to $1,300 every single year. Just to give you an example from a local area, this is the city of Lowell and Chelmsford, and we have the Merrimack River that flows through Lowell and Chelmsford. The diagonal blue and red hashed area is what's called a floodway. Basically, there is no legal way of building any kind of structure in that floodway because it's accepted that it's going to flood. But if someone lives in another area that's kind of in this blue zone or this orange zone, it has kind of different regulations in terms of you have to flood proof and have flood insurance for your home. So for the big picture, streams are complex. Systems are driven by the hydrologic cycle. We talked about how landscapes can be eroded, transported, or carved out by streams through erosion, transport, and deposition. And then floods are expensive, but we have ways that we can either adjust to them or prevent them. All right, so at this point, you should be able to finish the final streams quiz.